Before we talk about what an independent or mutually exclusive event is, let's just talk about what an event is when we look at the probability of an event. So if I'm looking at the probability of event A occurring, this is the probability it occurs. And then the probability of that is going to be between 0 and 1. 0 meaning it's not going to happen at all, 1 meaning it's guaranteed to happen. But really as we get closer to 0 and 1, it's just that more likely it will or will not happen. Now, we have that event there. We could have different events. We could say probability of A, probability of B, so on and so forth. But let's also think of what the complement is. So the complement is going to be the probability that not A occurs. So this is the probability A happens, this is not A. And we could also write it as an A with the line on top, or we could put in this form. So these all mean the same thing, they are the complement. And a complement is going to be equal to 1 minus the probability that A occurred. So let's just think of it as a decimal to start with. So let's say the probability of A is 0.35. That means the probability of not A is going to be 1 minus 0.35, or if you want to think in percents, 100% minus 35%, and that'd be 0.65. Together, they have to add up to 1. Let's think if we're rolling a 6-sided dice. So I've rolled a 1. So the probability that I would roll a 1 was 1 in 6. But what was the probability that I did not roll a 1, or not 1? Well, I could do 1 minus 1/6, which is 6/6 minus 1/6, or 5/6. So there's actually a far greater chance that I did not roll a 1 than rolling a 1. Now, these together add up to 6/6, or 1, because it does cover all of the opportunities. It either is, or it isn't. Now, let's say we were still rolling the dice and we said the probability that I rolled an even. Now, looking at my sample space, I know that there are 3 even numbers on a 6-sided dice. So that is a 1/2 probability. So the probability of not even, which would be 1 minus that, is also the same as the probability it's odd, because if it's not even, it's odd. But still, it's going to be 1 minus 3/6, which is 3/6, or 1/2. Now let's think of cards, if we're pulling cards. Let's say in my card deck, I want to see the probability that I pull a 7 of diamonds. Now I know there is 1 7 of diamonds in my card deck, so there is a 1 in 52 chance. But the probability that I not pull a 7 of diamonds, or its complement, is going to be every other card in the deck with the exception of the 7 of diamonds, which is 51 out of 52. And I got that because 1 minus 1 over 52 gives us that result. So make sure it always adds up to 1 if you combine the complement and the other event. Now let's look at a mutually exclusive event. So mutually exclusive events cannot happen at the same time. Impossible. So what that means is that the probability of A and B occurring is 0, because they cannot happen at the same time. Now this we're going to use for later. Okay, but we could have an or there. So it is or possible. Now let's think of our dice. Now what would be the probability of rolling a 4 and a 2? Well, I can't roll a 4 and a 2. It's not physically possible for the dice to go down and land so to be exactly a 4 or a 2. It could be a 4 or a 2 or something else. So this is a mutually exclusive event, so that probability is 0. But we bring up the special idea of or, and this is where we get our special rule of addition. Because and really limits us, but or gives us options. And this is where we're going to say the probability of A or B is equal to the probability of A plus the probability of B. So let's change it now to fit the probability of rolling a 4 or a 2. Now that's possible. Or means it's either a 4 or a 2. This means I can break it up to the probability of a 4 plus the probability of a 2. Now, 6-sided dice, I have 1/6 plus 1/6. I get 2/6 or a 1/3 probability. I roll a 4 or a 2. Now, if we were thinking about cards, the probability, if I pulled a single card, that it would be a ace and a face card is 0. I cannot physically pull both of those. It won't happen. But I could look at the probability I pull an ace or a face card, which means a different thing. So ace or a face card becomes the probability of an ace plus the probability of a face card. Now, the probability of an ace. There are 4 aces in a deck, and face cards, jack, queen, king, there are 12. There's 3 in each suit, and there's 4 suits. So combining those together, I get 16 in 52, which is 4/13. So that is the probability I get an ace or a face card. Now, we may see it in terms of cards or dice, but we also may start to see it in decimal form. So let's say I had a mutually exclusive event where the probability of A was 0.6 and the probability of B was 0.25. So the probability in this case of A and B occurring. Now, the values here don't tell me this answer. This comes down to knowing the rule, which we stated right here. The probability of A and B happening is 0. They can't both happen at the same time. Now, the probability of A or B occurring, though, is different. This is our rule here, where I can add them together, and I get 0.6 plus 0.25, which gives me 0.85. So the or here is actually 0.85, or 85%. Now, let's also throw in, what if I wanted the probability of not A or B? So this is the complement of this value. So that's going to be 1 minus 0.85, which comes out to 0.15, or 15%. Remember, these two have to add up to 1. So those are mutually exclusive events. The and is 0, the or, we combine the probabilities. The next one we have to look at is independent events. And this is where the first event does not affect the second event. So we could have them both occur. And we also may see these referred to as overlapping. Now in this case, the and is possible. And the probability of those occurring is the probability of A times the probability of B. Now this is the big difference to start off with between mutually exclusive. In mutually exclusive, the ands is a 0. Here we're going to multiply the two probabilities. Now, because there is an overlap, we also have to change our general rule for addition that we had. So the rule of addition now becomes the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B, which I'm going to try to show you in some examples. So let's say we are pulling some cards from a deck of cards, and I'm looking at the probability I pull a 7. Now there are 4 7s out of 52, and if I even write the sample space of this, I have a 7 of diamonds, a 7 of hearts, a 7 of clubs, and a 7 of spades. then if I'm looking at the probability that I pull a diamond, there are 13 out of 52 diamonds. And that starts at ace, and goes all the way to king. 13 of those. So let's start with looking at the probability that I pull a 7 and a diamond. So in this case, I pull a card, and if I pull a 7 or I pull a diamond, it really doesn't affect it. It's just something they may have in common, which it is possible, and that's actually the same as pulling the probability of a 7 of diamonds, because there is that card. So using the rule right here, I want to find the probability of a 7 times the probability of a diamond, which I have already done, which I have 4 over 52 times 13 over 52. I've reduced them, and this comes out to be, probably reduce them correctly would help, this comes out to be 1 over 52. So there's a 1 in 52 chance that I would pull a 7 and a diamond, or the 7 of diamonds, which should make sense. There's only one of them. Now, let's go to the OR statement. So this is the probability of a 7 or a diamond. Now, if I just did the probability of a 7 plus the probability of a diamond, let's look at that scenario. So there are 4 out of 52 are 7s, and 13 out of 52 are diamonds. And if I look at this group and I count them, I actually get 17 total. But 17 over 52 is not our correct answer. And the issue is this right here. This card, or these values right here, are the exact same card. This is the 7 of hearts. Try again. These two are the 7 of diamonds. They are the exact same. This shows up in both of them. This is an overlap. And the issue is, if I count 4 and 13 and stay 17, I'm actually counting this one twice. So this is where, in our rule up here, we have to subtract the and. And the and is 1 in 52. So now I get 16 over 52, which comes out to be 4/13. So you got to be careful on these and paying attention to that overlap. They don't want to double count, and that's what an overlap does. Now, let's say I have a couple others with independent events. Independent events C and D, where I know the probability of C is 0.55, the probability of D 0.4, and the probability of C and D is 0.22. So I'm going to first figure out the probability that C or D occurs. So here it's going to be the probability of C plus the probability of D minus the overlap, because that's what we get from our addition rule. That's C and D. When we think of OR, remember it could be both. That's why we got to subtract an overlap. Now, if you accidentally put this when there was no overlap, it would just be 0 and it wouldn't affect it, but it's good habit to put that there. So I got 0.55 plus 0.40 minus 0.22. 0.95 minus 0.22, and I get 73 hundredths, or 73%. Now, let's check the probability of not C or D. So in this case, I'm now going to do 1 minus the probability of C or D, which is going to be 1 minus 0.73, or 100% minus 73%, which gives us 0.27. Okay, well, what if I had independent events E and F? And now this time, what I know about E and F is that the probability of E is 0.75, and the probability of F is 0.2. So if I'm going to figure out the probability of E or F, I first have to do a little bit of work, because I know this is the probability of E plus the probability of F minus the probability of E and F. But I don't know this yet. So the way I figure this out is by saying the probability of E and F is equal to the probability of E times the probability of F, which is 0.75 times 0.2. So we get that's 15 hundredths or 15%. So now I can put these all together and I get 0.75 plus 0.2, 0, we'll throw a 0 on there, minus 0.15. This is 95 hundredths minus 15 hundredths, we get 0.80 or 80%. Now for our last example, we're going to look at this two-way table where we're comparing cars, trucks, and vans, as well as white, blue, silver, and black colors out of 500, let's say cars or vehicles in the parking lot. So let's start working our way through some of these. So if I started with the probability that I would pick a car out of all of these in the lot, and that's saying I'm looking at this column, and there are 125 out of 500 cars. And that reduces to be 1/4. If I then said, well, what about the probability I have a white car? A white car, or a white vehicle, I should say. Probability it's white. I'm going to add up all of this column, and I get 225 over 500. And this becomes 9/20. Now, let's start putting these together. What if I said the probability it's a car and it's white? Now, if it's a car and white, it has to meet both conditions. So it has to be in this column, and it has to be in this row. And there's only one that does that, and that's the 100 right here. So this is going to be 100. So this is going to be 100 over 500, or 1/5. So it's car and white. Now that's different than if it was car or white. Now by these being independent events, because it really doesn't matter if a car is white, or if car is the vehicle or that it's white, we're going to use the probability it's a car plus the probability it's white minus the probability it's a car and it's white. And we can see this by looking here, because if I just took the cars column and added up these numbers, 100, 15, 5, and 5, I get the total for the cars. If I took the white, 100, 75, 50, and got 225, I double counted this 100. I don't want to do that. I actually just want each of these values once. So by subtracting the overlap, or that 100, it's going to give me an accurate value. So the probability of the cars was 125 over 500, plus the probability it's white was 225 over 500, minus 100 over 500. Now I get 125 plus 225 is 350, minus 100, it turns out to be 250 over 500, or 1/2. Now, let's think we had the probability that we picked a silver vehicle and a black vehicle. Silver and black, these actually cannot happen at the same time. Silver is here, black is here, and there's nothing overlapping, so they can't occur there. These are going to be mutually exclusive, so we make that at 0. But that doesn't mean it's impossible, because what if we said silver or black? So silver or black, it could be in this column and it could be in this column, and they're independent because they could both happen. So I'm going to do the probability of silver plus the probability it's black, and I'm going to subtract the probability it's silver and black. But we've already said that's 0, but it's worth paying attention to. Maybe that does show up. It's good to be careful as we do that. So silver is 75 over 500. Black is 140 over 500 minus 0 over 500, and we get 215 over 500. Okay, well, what if we said the probability it's black and a truck? So black and a truck, that means it has to be in the black and it has to be truck. So the only thing that has in common here in the and is the 100. So that's going to be 100 out of 500, or 1/5. How about the probability? How about the probability it's not a truck? So I could take the probability of it being a truck and subtract it from 1, or I can look at the options. So let's see this. If this is the truck, I could take 240 1 minus 240 over 500, which is, this is just 500 over 500, and I get 260 over 500, which becomes 260 over 500, ultimately 26 over 50, or 13 over 25. Now, one last one we'll look at is the probability that it's not a van and it's black. So probability it's not a van and it's black. So I'm going to first find this probability, because the probability of not a van is going to be important. So a van is this column. So that's 135 out of the 500. That leaves 365 left over. But that has to be black. So it's actually these right here. And what we could start to do when we get more specific is you can eliminate this column and you can eliminate the others. So it has to be that 105 over 500. Which would be 21 over 100. And as you start to do these, you'll start to just eliminate them, because really it's not being not a van, it's the fact it's a car and a truck, and it has to be black. So which of those would also work?